Hello and welcome to another one of Dee's ADD videos. We're going to look at this intermediate example that we did use in the concept video. It's an intermediate because the coefficients of the electrons aren't 1. So if you remember, if we check the activity series, we end up with silver is right here and calcium is way up here. So because calcium is a solid and above on the list, it is easier to oxidize. What does that mean to you? Well, that means that calcium will easily give up its electrons so that silver can pick them up. And when it gives up its electrons, they literally switch places. Silver becomes the solid and calcium goes into the solution with whatever anion is present. Alright? So from that tells you which one's undergoing oxidation, which one's undergoing reduction immediately. You should look at the half reactions next. So because Ag is plus, two things can be determined from that. One, the electron has to be on the left side. It will undergo reduction. But remember, it's the oxidizing agent. Why is it the oxidizing agent? Remember, the oxidizing agent is what undergoes reduction. So it's going to be able to accept the electrons. That's why it's called the oxidizing agent. Whereas the other half reaction for oxidation would be containing the reducing agent because it gives up the electrons so that reduction can take place. So in this case, oops, I forgot the other half of this. And then oxidation is going to be the calcium giving up its electrons. How did I know it was 2 electrons? I consulted the activity series. Okay. If you look carefully, calcium 2 plus, 2 electrons. So then, let's label our reducing agent. It's reducing why? Because it's giving up these electrons so that reduction can take place. Well, that's why it's called a reducing agent, because it donates these guys right here. This is called an oxidizing agent because it's going to accept these guys. And the way we balance the equations in this case is we have to multiply the top equation by 2. Reason being, the electrons have to be containing the same coefficient. Otherwise, they will not cancel when you add these two equations. So what you do is you multiply this whole equation by 2. And when you do so, you get 2Ag plus electron, 2 electron, plus CaS gives you Ca2 plus aqueous plus 2 electrons plus Ags. Oh no, plus 2 Ags. Okay? Now at this point you should be able to see your electrons are the same and they do cancel. You can subtract the 2 E's on both sides. So your final answer would be, and now this is balanced using the activity series and your knowledge of redox reactions. Right? So I hope I've clarified things a little bit. Practice, practice, practice as always. Thank you and have a nice day.